This topic came up at the recent peer user group conference at Puget Sound Energy. On the screen, you see a relatively complex pole callout. In this case, the callout has 6 lines: the pole, 2 transformers, a capacitor, a feeder riser, and a cutout. For this particular client's implementation, everything is proposed right now, that is new, and so everything appears green. But what happens if the components on the pole have different status values? For example, what if it's an existing pole, but a new transformer? I know of at least 3 utilities where the standard in this case is to display the callouts grouped by status and to use a different color for each status. Is there any way to do this in AUD today? So here's an example. I'm going to select the 15 kVA transformer. The pole and all contained components appear in Quick Info with the transformer selected. I'll now change the status of the transformer to existing unchanged. In the callout, which is being dynamically updated as changes are made, the transformer line in the callout changes to yellow and it moves to the bottom. I'll next select the riser and also set this to existing unchanged. It changes to yellow and it moves to the bottom. Next, I'll choose the capacitor and in this case, set it to demolish, remove. The line in the callout changes to red and it moves to the bottom. Finally, I'll change the status of the pole itself and make it existing unchanged. The pole in the callout changes to yellow, but in this case, because it's the pole, it stays at the top, because I decided it should really stay at the top. This is essentially what many clients want, is the ability to see these things sorted and colored by status. This was entirely done with basic AUD functionality, no special programming required. It just requires that you be clever. There are 4 elements to the solution to this problem. First, we'll need a callout block with 3 attributes, 1 for proposed, 1 for existing, and 1 for removal. The colors will be assigned to the attributes. Next, we need an expression rule to define the content to display for each feature class, a rule for the transformers, a rule for the capacitors, and so forth. If you've already created your callouts, you may already have defined these expression rules. Third, we need 3 rules that will assemble the content for the proposed items, for the existing items, and for the removal items. And finally, the most tricky part is we need to figure out a way to handle the spacing. And I'll touch on this a lot more as we go on. I'm going to start with the callout block. Here's an image of the block. It's like any other block with multiple attributes, but there are 3 main differences. First, all the attributes are stacked on top of each other. They all have the same insertion point. Second, all of the attributes have top left justification. You could also use top right, but you cannot use middle left or middle right justification. You'll see why later as we continue the video. And finally, either the layer or the color of each attribute needs to be specified. You have to ensure that when this block is placed within the drawing, it does not use by block or by layer coloring for the attributes. In this implementation, I've essentially assigned a specific layer to be used for each attribute. Okay, the next thing on the list was to have an expression rule for each component's callout content. These expression rules are defined within the text section for each feature class. For example, here's the rule for the callout for transformers. It includes the transformer's kVA rating, followed by the letters kVA, the secondary voltage, and the phase, displayed by another subrule in this case. Here is another example, in this case for the cutout, which shows the switch number attribute or an error message if the designer hasn't entered that data. And for fused cutouts, it also shows the fused value in parentheses. For this implementation, there's a rule like this for every type of pole-mounted component. Now we need rules to assemble the content for each status value. It turns out this is mostly easy because of the frankly underappreciated AUD general function list to text. Here's an example for proposed components. Let's look closely at how this function works. At its heart, it creates a text string from a list of components. The first few items define the list. The list in this case will be the features contained by the pole. This will be part of a pole expression rule, so the contained features will be the features contained by the pole. These features will be grouped together by the feature class. So transformers will be grouped with other transformers, risers will be grouped with other risers, and so forth. And there's a filter included, in this case, to limit the contained features to only those with a proposed status. The remaining function parameters define the text to be generated. The text for each contained feature depends on the feature class. The choose_value_where function considers each feature class and uses the callout rule for that feature class. Remember, just a minute ago, we talked about the rule for cutouts, which are in the sectionalizer feature class, and the rule for transformers, and they appear here. Finally, we also specify a delimiter. This determines what appears between the text generated for each contained feature. Here, I've specified that a new line is the delimiter. Now, our example was a pole, and it contained two transformers, a capacitor, a riser, and a cutout. If all the components have a status of proposed, here's the result generated by this function. This is pretty darn close to what we want. And if we wanted to change this function to work for existing components, we'd just have to create a second function with a different filter. Before I go on, there's one more thing I want to point out. Note that transformers appear last in the list. It turns out that the list_to_text function doesn't provide you with any control for the order of the groups, and since transformers start with a T, it always appears near the end. I want the transformers to appear at the beginning. We'll take care of this near the end of the video. So now we have all the pieces. Now the challenge is to put it all together. On the screen, you see the final image of the demo. The pole is existing and appears at the top. Then the contained devices that are proposed appear, with the transformer first, followed by the existing contained devices, again with the transformer first, and finally the removed devices. Remember, these are represented in the callout by three attributes. So here is the content of each of the three attributes. The proposed content has three elements. A space for the pole information that appears only if the pole is proposed. Proposed transformers, which we're handling separate from the rest of the list so that they always appear on top of the other proposed components. And then any other proposed components. The existing content has four elements. Again, a space for the pole information that in this case only appears if the pole is existing. Then a gap where the proposed components can show through. Proposed existing transformers, again separated so they appear before the other existing components, and any other proposed components. And removed components, which also has four parts, except that the gap has space for both the proposed and the existing components to show through. Now let's look at the rules that create this content. Here's the rule for the proposed content. Remember I said there would be three parts. These three parts are being glued together by the concat string function, which concatenates multiple text strings. The first part uses the general function conditional text. If the pole is proposed, then the pole callout appears followed by a new line, and otherwise only the new line is generated. In our example, the pole is existing, so there's just a blank line at the top. The second part also uses the general function conditional text. This generates the transformer content. If there's at least one proposed transformer contained by the pole, then the list_to_text function is used as we saw earlier in the video. However, the filter limits the list to only proposed components that are in the transformer feature class. If there's no proposed transformers on this pole, then the second part will return nothing. By including this part in the overall function, the transformers appear before the other components. And the third part uses the list_to_text function with a filter that again limits the list to only proposed components. But this time, however, it also filters out transformers, since they were already handled in the second part. Okay, now let's look at the rule that generates existing content. It has four parts, three of these nearly identical to the last rule. The rule starts like the last rule, using the general function conditional text. This time, if the pole is existing, then the pole callout appears, followed by a new line. Otherwise, only a new line is generated. This time the pole is indeed existing, so the rule generates the pole callout as shown. The third part here is just like the second part in the previous rule. This generates the transformer content if there's at least one existing transformer contained by the pole. It has the same limitation that only existing components in the transformer feature class are considered. And here's the fourth part, which is just like the third part in the previous rule. It uses the list to text function with a filter this time to show only existing components, with the exception that transformers aren't included because they just got handled in the previous part. Now we get to the tricky part. We need to include enough new lines to provide space for all the proposed components to appear. How many new lines are needed? We need a count of all the proposed contained components, which in this example is 2. So the expression to determine this count is shown here. The number of contained electric points where the status is new. The tricky part was how to figure out how to insert the right number of new line characters. I've created a text expression new line string that looks like this. It's just a string that contains a long series of new line constants. And then I'm using the left function in combination with that text expression. What's tricky about this is that each new line actually consists of 2 characters, what would be called a carriage return followed by a line feed. The left function is counting single characters, so I have to first multiply the number of characters I need by 2 to get the right result. Okay, so we're on to the home stretch. Here's the rule for the removal content. This rule is very similar to the last rule, except for 2 things. All of the filters are looking for removed components. And the second part, the part that provides space for the proposed and existing components, counts all of the contained components that are not being removed, because that's essentially all the proposed and existing contained components. So now I've covered the 3 rules that create the content for each section in the callout. All that remains is to put those rules into the definition of the callout itself. Here's that definition, and you can see here are the 3 rules, 1 for each of the attributes. Let me reiterate the core elements in this video. As stated at the beginning, there are 4 parts to the solution of this problem. First, the callout block. I created a callout block with 3 attributes, 1 for proposed, 1 for existing, and 1 for removal. The colors, or layers in this case, will be assigned to the attributes. Next, I reviewed 2 of the required expression rules that were created for each feature class. These are the basic subrules that you'd create for any component with information to display in a callout. Third, I covered the components within each of the 3 expression rules that assemble the content for the proposed items, for the existing items, and for the removal items. And fourth, as part of this, I covered how the spacing within rules creating the existing and removal content should be handled. And that's it. If you have any questions or want more information about clever configuration approaches to AUD, contact me at dan.layton@dl-consulting.net.